Now come to the kinetic friction. Till now we have discussed the body was at rest, but it has tendency of motion. Because of that, a friction force acting opposite to the direction of tendency of motion. Now, once the body start moving, then the friction force, which friction force act on the body, that is called your kinetic friction. So we can write, when there is a relative motion, between the contacting point or between contacting points or contacting surface when there is a relative motion between contacting points or contacting surface, then there is a friction force act. Then there is friction force act between the contacting surfaces, and it has, that friction force is known as kinetic friction. So that friction force is known as kinetic friction. Kinetic friction force, and this we are normally representing with the Fk, K for kinetic. Now certain point related to that, the direction of kinetic friction force, is always opposite to relative motion of contacting point. Opposite to relative motion of contacting point points or contacting surface. So let, for example, suppose this is one of the body. This is the body which is moving with a speed 2 meters per second. So this body, see this contacting surface. This body moving rightward with a speed 2 meters per second. The contacting point have velocity in that direction. So friction force your act on that body or in this direction. So if we are making a FBD of this body which is moving in this side with speed 2 meters per second, so see the contacting point of this body moving in that side, the friction force Fk in this direction. And now if we are looking for surface friction you're in this direction. So we can say another point also, friction force is always it is your action reaction force. So second point we can say, friction force always action reaction force. Friction force is always action reaction force. So whatever force acting on one of the body, same force will act on the another contacting surface, but both forces will be in the opposite direction. So both the contacting surface will have friction force but in opposite direction. Both the contacting surface have friction force of same magnitude but in opposite direction. And third important point here, kinetic friction is directly proportional to normal force. Kinetic friction is directly proportional to normal force. We can say Fk is proportional to normal force, and when we are leaving or removing the proportionality sign, we will get a constant mu k into n. So where mu k is a constant known as coefficient of kinetic friction. Where mu k is constant, known as coefficient of kinetic friction. And this value of kinetic friction force here always constant here. So kinetic friction is always constant between the two bodies. Kinetic friction force always constant for given surfaces. It only depends on the normal force acting on the body. It depends on normal force. So now see 1-2 more points related to kinetic friction and some examples. See, as we have found, kinetic friction is always given as mu k into n. So it depends on the normal force. As we are increasing or decreasing normal force, our value of kinetic friction here constant. It depends. And for a given normal force, our kinetic friction force will be your constant. So another point we can say, fourth point, it has been observed, it has been established that coefficient of static friction mu s is always greater than the coefficient of kinetic friction. Coefficient of kinetic friction mu k. It means mu s is always greater than mu k. So maximum value of friction force is nothing. It is the maximum value of static friction force. Fifth point. The kinetic friction does not depend on the velocity, magnitude of the relative velocity between the contacting surface. Kinetic friction force does not depends on magnitude of relative velocity between contacting surface. It means once relative motion start, whatever the relative velocity between the two contacting surface, our kinetic friction is always constant. So for example, we can say, let mass of the body is your 2 kg, g value you are given 10 meter per second square, and mu k is equal to let 0.4, and body is moving in this side with speed 1 meter per second. Then what is the friction force? First thing is that since the body is moving, so there is a relative motion between the surface of the body and the ground. So there is a kinetic friction. The Fk, kinetic friction always given as mu k into n. Mu k into n. First we will determine what is the value of n. When we are making FVD, so in the FVD we have to show the forces. One here your normal force, another since the body moving in this side, another force is your friction force Fk in that direction, and third force is your mg. Since there is no motion in the vertical direction, n is equal to your mg, so Fk is written as mu k into n. So from here we can say Fk is equal to your mu k into n, and n is your mg. So mu k value 0.4, m 2 kg, and g is your 10. So this is your 8 Newton. This is the value of Fk. So in this manner we can simply calculate the kinetic friction force value. The main thing is that the determination of the normal forces. Normal forces can change in different conditions. Suppose if any external force acting, let for example, in the same question here, suppose another force acting here 2 Newton in this direction. In that case, if we are talking about, so our equation will be your upward force your normal, downward force your mg, and 2 Newton. So total normal force will be your mg plus 2. Mg here, m is 2, g is your 10, the mg will be your 20 plus 2, 22. The normal force will be your 22. So here normal force we will write 22. The Fk will be 0.4 into 22. Then our friction force value will change. So main point here, normal force as changes, our kinetic friction also your changes. But the mu k value is greater than your mu s. And in the second thing, as I said here, kinetic friction force does not depend on the magnitude of the relative velocity between contacting surface. According to that, right now our block is moving with speed 1 meter per second. Suppose the speed of the block has been changed from 1 to let 2 meter, let 3 meter, 4 meter, whatever the value, but our kinetic friction value will remain constant. So this is the meaning of a kinetic friction. The kinetic friction will start acting only when there is a relative motion between the two contacting surface. And now see the next point here. If we want to make a graph between applied force and friction force, graph between applied force F and friction force F. Then see how we can get. So we are taking the applied force along your x-axis, friction force is your in y-axis. F is nothing, it is your applied force. So it can be seen in the better way if we are making with a diagram. So this is our body, and mu s and mu k value are given. Mu s is the coefficient of static friction, mu k is the coefficient of kinetic friction. As we have established, mu s is always greater than mu k, and Fs maximum value is always equal to your mu s into normal, while Fk kinetic is always your mu k into normal. Now, if we are applying some force, that is called your applied force. So what we have observed, till the body is at rest, then the friction force is your always equal to your applied force. So now the graph will start like this. And now, as soon as the friction force, applied force is exactly equal to your static friction, maximum value of static friction, we can say this is your Fs maximum, and that Fs maximum is your Fs maximum, and which is your mu s into n. Immediately body start moving. As soon as the body start moving, then the kinetic friction start acting, and that remain your constant. So immediately kinetic friction start like that. So this is your kinetic friction, and this is your static friction. So this type of graph we will have. So once body start moving, so kinetic friction does not depends on the applied force. So whatever the value of applied force, kinetic friction will remain your constant. So this type of graph is there. So what we can say, static friction is slightly more than the kinetic friction. Now come to the next point, angle of friction and angle of repose.